Guys, here we are. We're back here in section 4.4. We're going to talk about determinants and then how that applies to Cramer's rule. And Cramer's rule will help us find the point of intersection, much like the substitution rule and the addition rule or elimination rule, just a different way of using matrices to solve. So let's talk a little bit about what a determinant is. The determinant of a 2x2 matrix is the difference of the products of the diagonals. So you just do a little crisscross applesauce, as I like to say. So if you're finding the determinant of the matrix 1, 2, 3, 4, take 1 times 4 and then subtract 3 times 2. And make sure you always go in that order, okay? And there's a little reference right here you can look back at if you want to, if you forget which way. But just go, the first A times D minus B times C is what you do there. All right, so let's just practice a few of those, see how it works. Yeah, good point to make here. A lot of times we can say DET of A, or if it doesn't have the square brackets, just it looks like absolute value actually. It's not though, but that just means that's what we want you to figure out the determinant. It's another way of writing it down to do that. So again, we're going to find the determinant of the matrix. So once again, we're going to go crisscross applesauce. 1 times 8 is 8. And then we're going to subtract 4 times 5, which is 20. And of course, then our determinant would be negative 12. And again, we'll show you an application of, okay, what does that number tell you? How is it useful? So we'll get to that in just a second. But we want to make sure you know how to do it first. All right. There we go. Ooh, let's do this one. Oh boy, threw some fractions in there. Oops, I put the wrong thing there. Oops, let's go back up. There we go. Hit the wrong button. All right, so crisscross applesauce. Let's go half of 2 is 1, and we're going to subtract. Ooh, let's see, negative times negative is positive. That'd be a positive 1/2. And so we'd get 1/2 for the determinant. Okay, so pretty easy to do 2x2s. We'll talk a little bit later on 3x3s, how to do those, and we'll show you some calculator things. For the 2x2s, unless the numbers are really icky, I wouldn't do it on the calculator. I just do it like we do here. And it's just as easy and fast if you do it that way. So, all right. So let's talk a little bit about solving. If we want to solve the system of linear equations, make sure that we put it in standard form. In other words, let's make sure we do put the x term plus the y term equals the constant. Make sure we put it in that order for both. And what we're going to do is we're going to take the coefficients. You can kind of see there, you just kind of move down into the matrix. And that's the coefficient matrix that we're going to talk about. We're going to want to find the determinant of that. That's going to be vital as far as using Cramer's rule in order to do that. And then we'll show you how to use the rest here. Okay, so that's what we want to do. D is the determinant of that matrix, and that's the formula here. So Cramer's rule looks a little intimidating at first, but we'll kind of get used to this. D is just that determinant of the coefficient matrix. That's what we're going to look for. And then to find the top, if find the x value, you replace the a's with the c's, and then find the determinant. And then for the y's, you replace the b's with the c's values. And again, then that'll give us our point of intersection. Let's just kind of show you how that works. Before we do that, Cramer's rule will actually tell us what type of system we have. If D is anything other than 0, it's going to have a unique solution. Now, if the D is 0, we know we can't divide by 0. Okay, so we know that gives us a problem. If at least one of the numerators is 0, then it's infinitely many. And if neither numerator is 0, then that's where we have no solutions, is what we have. So that's how to tell in Cramer's rule what happens here. Okay, so we already told you this one's going to have this solution. First thing first, I want to make sure I have this in standard form. So I have a 2x plus y equals 10 and a 3x minus 2y equals 8. And make sure you have it x, y equals a number. That's what you want as we do this. So let's go ahead and find D first. Let's see, yeah, let's just do that right here. Okay, so D, we're going to put those coefficients 2, 1, 3, and then negative 2. All right, so let's see what we have. Crisscross applesauce, we're going to get negative 4, and then we're going to minus 4. I'm sorry, negative 4 minus 3, that's going to give us negative 7. Negative 7, that's the D value. All right, so now to find x, what we're going to do is we're going to put that negative 7 on the bottom. We're going to find the determinant. Now, since it's the x, we're going to replace the 2 and the 3 with the 10 and the 8. We're still going to keep the 1 and the negative 2 there. All right, so there we go. I guess we're going to get 4. Let's see, we get negative 20 minus 8. That's negative 28 over negative 7. Oopsie, my finger's not writing very well today. All right, negative 28 divided by negative 7, that does give us 4. How about that? To find the y value now, all right, we're going to put that negative 7 down below. That's what we do that for. Now this time we keep the x coefficients the same because we're finding y. We're going to use the 2 and the 3. And then in place of the y coefficients, we put the 10 and the 8. All right, so we'd get 16 minus 30. That would be negative 14 over negative 7, which indeed gives us 2 for that value. So again, Cramer's rule, kind of a slick way of using matrices, the determinants, in order to find the solution. That's where it crosses. Kind of neat. Okay. All right, let's clear that out of there. We'll close that up and move on to the next one here. All right, so we got, all right, now again, we're going to use Cramer's rule to solve the system here. Now the first thing we're going to do, you notice this one is not in standard form. Let's do that. Okay, so there it is. All right, so it's in standard form now. X, y equals a number. All right, so let's get our pen ready to go here, and let's do our D. D, this is what's going to go on the bottom. All right, so we're going to go 3, negative 2, 9, and negative 6. Whoopsie, there we go. Now, what's going to happen here is we're going to get negative 18 minus negative 18. That's going to be 0. Uh-oh, SpaghettiOs. Okay, so we know something crazy kooky's happening. We're either going to have infinitely many solutions or we're going to have no solutions. Let's see what happens when we figure out the tops. In other words, when I'm doing the x, remember the x, what we do is we put the negative 5 and the negative 15 in for the x coordinates, and then we keep the negative 2 and negative 6. So there we get 30 minus 30. That's going to be 0. Okay, so yeah, what's happening? Okay, well, let's check the other one. Let's do the one with the y. Let's put the 3 and the 9, and put the negative 5 and the negative 15. And in this case, we're going to get negative 45 minus negative 45. That's going to be 0. Okay, so let's go back up to our rule. So yeah, it looks like if they're both 0, if the bottom's 0 and they're both 0, that means it's going to be infinitely many solutions. If one of those, either the x or the y, if that numerator there would have been anything but 0, then it would be no solutions because you can't have a number divided by something else. But if it's 0, that just means it's 0. Infinitely many solutions is what we have there. Okay, well, there we are. All right, well, there we go. Now, again, we might say, what about if we used a 3 by 3? How do you find the determinant of that? Here is how you would do it by hand. Okay, basically, you're going to take the A column, put it next to the C column, put the B column over there, and then you're going to diagonally go where the reds are going right there. And then you're going to subtract the blues. And you're looking at that, you're like, ay caramba. Okay, yeah, not really the fun way of doing it. Lots of places where you could make some errors, obviously. All right, so if we were to find the determinant of this, yeah, we'd have to write those down. We'd have to do our little crisscross applesauce. Okay, yeah, get all those down. And then we'd have to, okay, get those, and then we'd have to multiply up. Doom, doom, doom. All right, so we've got those, and then what we'd have to do is take the 64 minus the 186. That would be the determinant. Okay, so there we go. Now, we can also use the calculator, which I would say anytime you have a 3 by 3, I would definitely use that calculator. Now, what I've already done is I've already stored this matrix. I'll show you matrix. Let's see, I've already looked at that. Let's go over here and show it to you. I think I've got it typed in there. Yeah, so there's our original matrix. Just got to type that in for matrix A. All right, and then what we're going to do is we're going to hit second matrix. Now, when we go over to math, right away you see DET, that's determinant. And then we just have to say which matrix it is. Just hit matrix and then go A. And I'll close that parenthesis, and there we go. Oh my goodness, is that way easier. All right, so again, kind of used to those keystrokes on the calculator there. It's some nice tools to use. I would definitely, for 3 by 3 matrices, I would definitely use that. All right, so on your note sheet, it does have Cramer's rule for a 3 by 3. You can certainly look at that. I don't think we're going to get anything. It'd be a little bonus question if we were to chance something like that, but that's a little hairy there. So, all right. So again, 4-4, dealing with determinants and Cramer's rule. Good luck with everything. Always, as always. Let me know if you have any questions. Until next time, I'm Mr. Boone.